In this video, we're going to talk about the difference between an array and an area model. An array is a visual representation of a quantity that you have, and it's oftentimes represented in pictures. Like here I have a 4x3 array of hearts, and if I counted them all up, it would represent how many hearts I was talking about in that problem. Or if I multiplied them 4 times 3, I would also get the number of hearts in my total array. It's a visual representation. It's not one that we use too often in class because it does mean that you have to draw out every single object, which for 12 hearts isn't so bad, but let's say you had 40 by 30, all of a sudden you're drawing a ton of hearts, and it's not really the most efficient way to visually represent your problem. Area models, on the other hand, are much easier and much faster to draw because you're really only talking about the area inside a square or a rectangle. For example, this area model here is 7 by 8, and it models the area of 56 because there are 56 squares inside this area model, and if I drew it on grid paper, I could make it exact and I could count them all up. The nice thing about an area model is you don't need to count them all up because you can trust that the area of a rectangle that is 8 by 7 is really 8 times 7, whatever the product of that is the number of squares inside each area model. Now, area models can be drawn on grid paper. Again, you run into a similar issue that you had with the arrays of having to count. And an 8 by 7 isn't so bad, but let's say you're talking about 150 by 400. All of a sudden you have to glue grid paper together, or you have to have really tiny squares. The nice thing about area models is you don't have to draw them on grid paper. If you understand the concept, you can just draw a rectangle and label its two sides. So this area model is a 3 by 4. 3 times 4 has a product of 12, and I know that inside this rectangle, that is the area that I am talking about. Area models represent the area, not the dimensions. So this is not an area model of 4, it is not an area model of 3, it is an area model of 12. And if I were drawing area models of 12, I could draw a different one too, because 3 times 4 is not the only factor pair to get to 12. I could have an area model of 1 by 12. I could also have another area model of 2 by 6, because ultimately the area of each of these rectangles is 12. Now, I wouldn't go ahead and draw myself another 4 by 3 because that wouldn't be a distinct area model. That would just be this one right here turned on its side. And I'm looking for distinct or different area models, not repeats that just got turned 90 degrees. So I would not include this one if I were drawing area models. I would have 1, 2, 3 distinct area models to represent the area of 12. And that's only with whole numbers. I'm not going to get into fractional area models or decimals, but when we get there, we could do those as well. So, taking a quick look, here are the area models for 22. I have 1 by 22 and 2 by 11. I know that I can't have any others because if I draw myself a factor rainbow for 22, I have 1 times 22, those are factor pairs, 2 times 11, those are factor pairs, 3, nope, 3 won't work because if I find my digital sum, 2 plus 2 is 4, which is not equally divisible by 3, so 3 is out. 4, no, I know 4 doesn't work because if I double 2, I'd have to have 11, and half of 11 is not a whole number, and for factor pairs, I'm only looking for whole numbers. I'm pretty sure that's it. Those are my only 2 factor pairs, so I only have 2 area models. 22 is a composite number. If I were to take a prime number, let's say 7, the only factor pair is 1 and 7, so I would only have 1 area model of 1 by 7. It's an area model of 7 because 7 times 1 equals 7, and that is the area that I'm talking about in the area models. In class, we will most frequently be using area models as opposed to arrays. However, you might see a problem with an array in it, maybe like a little drawing of what does this represent, how many does it represent, or asking you to divide them equally. Arrays you should know about, but area models are what we're sticking with in class.